Thermodynamics 5. Calorimetry. If there is no heat loss to the surroundings, the heat lost by the hotter object equals the heat gained by the cooler ones. That's why we use a calorimeter, which consists of a calorimeter cup that is from a known material and a known mass. It's filled with, in this case, water at a known mass, and then there's an insulating container around it that prevents the heat loss to the surroundings. Then we can take an unknown material and put down in the water, and then we can wait for equilibrium. That means that all materials have the same temperature, and then we can calculate on it. Example 6. Measuring the specific heat capacity. The calorimeter is made of 0.15 kilograms of aluminium and contains 0.20 kilograms of water. Initially, the water and the cup have the same temperature of 18 degrees centigrade or Celsius. A 0.040 kilogram mass of unknown material is heated to a temperature of 97 degrees Celsius and then added to the water. After thermal equilibrium is reached, that means the cup and the water and the unknown material have the same temperature, then the temperature of the water, the cup and the material is 22 degrees Celsius. Ignoring the small amount of heat that gained by the thermometer, find the specific heat capacity of the unknown material. We know that the heat removed equals the heat supplied. That means that mass multiplied by specific heat capacity multiplied by change in temperature of the unknown material equals mass of water multiplied by specific heat capacity of water multiplied by the water's change in temperature plus mass of the aluminium multiplied by specific heat capacity of aluminium multiplied by the change in temperature of the aluminium. We want to find the specific heat capacity of the unknown material, so that's what we isolate. We isolate it by moving mass and change in temperature over on the fraction line on the other side of the equation sign. Then I can put in some numbers. The specific heat capacities I find in the table on page 293. Then we have the masses and the changes in temperature. And if I calculate that, we have a specific heat capacity of 1300 joules per kilograms multiplied by Celsius degrees.